Viewpoints, high performance visualization, and analysis tools.
So, originally I was going to have the main developer of this tool come and talk about this. He's in the NASA Ames Supercomputing Center, where they have a big Viz group. And they, as I've said before, they've been there a long time. They've done wind tunnel testing and things like that. So they're quite good at coming up with ways to visualize data. And I showed you in this morning an example of something called the hyperwall. And I showed you that was an expensive way to do visualization compared to some of the other techniques that are out there these days. But I guess about 5 or 6 years ago, we decided we wanted to put the hyperwall on our desktops, basically, because the hyperwall is a specialized machine that you can build for, say, $50,000. It's nice if you've got 50 grand lying around. But it'd be nice to have something that runs locally where you can do some initial data exploration, prepare yourself, if you need to get ready to go to the hyperwall so that you can tell them what you're looking for, which is a huge boon to the guys running the hyperwall when you bring your data in. So you can help them stage the data in a sense and be more efficient in its use. But in the end, we ended up starting using this all the time for ourselves, looking for data outliers and things like this. So I'm just going to talk about it for a few minutes, and I'm going to do a really quick demo. I'm not as good as Creon, the main developer, at the demo, because he built most of it and he knows all the intricacies. But I can just show you some of the primitive stuff that I use it for, at least for the scientists in the audience. They'll get something out of that. Okay, so as I said, it's like a hyperwall for the masses. The idea is that it's something you could run on your workstation, in your office or your laptop, multiple views. So the idea is to be able to look at high-dimensional data using linked scatter plots, which I showed you in those first slides this morning with brushing. Ability to use dynamic histograms, again, outlier detection, removal, and relatively performance on what? Well, here, large data sets. I'd say on my laptop here, this is a 2-year-old MacBook Pro. I can look at data sets with, say, a couple million points. With about 20 features per point, something like that. So that's the kind of data sets we're talking about that'll work on a machine of this scale. So this is the back of the hyperwall. This is this expensive, customized thing that they built at NASA Ames. They built a couple of these for other people, and they've expanded this. This is what it looks like in front. Again, it's a 7x7 display wall. Not what we normally think of as a display wall. You can also use it to do super resolution stuff, but really the main task here is to look at data in different views, the same data set with different features or linked scatter plots, which I'll show in a minute. So it's been used for all kinds of things, quantum chemistry, which I touched on a little bit this morning, CFD, virology, machine learning, finance, and of course, astrophysics, not surprisingly. It's built around some open source tools. It's very easy. And in essence, it's written with C and OpenGL, so it can make use of fast graphics abilities in cards instead of using system CPU. So most of the Viz tools like this that have been used in the past were using the computer CPU, but now that visualization cards are getting so powerful, you offload everything onto the vector processor and you can speed stuff up. So as long as your data set, the rendering can fit inside of the graphics GPU memory, your data rocks, basically, can fly the data pretty quickly. Okay, and it runs on these 3 platforms. We had some idea in the very beginning. We still, of course, we're NASA, so we have lots of archaic equipment around. We didn't try to get this run on any VAXs, but we did have the idea to get it run on Solaris, but I think we killed that off. Or Sun's killed it off anyway. I don't think Oracle's going to resurrect much in that sense. And it is open source, so one of the things about it is that we've gotten some developers from different places to help contribute code to it. So if you want to contribute something, you want to add some functionality to it, you can pull it down, compile it, and play with it. I mean, that's the beauty of it. And again, it's cross-platform. If you get it to compile on your Linux box, it'll compile on these other 2 platforms as long as you have development tools installed. Those things I showed you before. Okay, just some enhancements. We've worked on the user interface quite a lot. Some dimensionality reduction stuff, clustering, mutual information. Some of this stuff is not completely implemented just yet. Some threading, shading, things that we've helped with performance. So let me try to show you just very quickly a little bit of its capabilities. And of course, since we've talked about the Sloan so much, and I knew we would, since I got to look at everybody's talks beforehand, I thought I would play with some Sloan data very quickly here. So this is Sloan Digital Sky Survey release 7, or at least part of it. And here you see the top, the North Galactic Cap. And we have some other pieces down here. And I plotted up some different aspects of this data. So on upper left is just the positions on the sky. That's not so interesting. But here you have a color magnitude plot. So this is the G band and the x-axis. You can see if I can plot any one of these magnitudes, U, G, R, I, Z, plus the absolute magnitudes calculated from the Sloan, which you can get all the way out to K band in the infrared. Redshift error I can pull up, and then again these colors that I've set up beforehand. Here I've plotted redshift versus absolute magnitude in R. For people that know about volume limited surveys, you might know why I would like to do that. Here again is absolute magnitude in G, again G minus I. So these are just color filters for those of you that aren't familiar with the data. And so here I've just plotted up, for example, the histogram for this particular data set. But I might be interested in a certain subset of this data. So for example, I might be interested in maybe half this data set. And as I highlight those, first of all, you can see that the selections in the histogram will show up. And any point I've selected in this data set will show up in the other plots that I've set up immediately. So that's the part about the linked histograms, the linked scatter plots. So in the upper right, first of all, you can see that also I've got a lot of outliers. This data's dirty still, so I can clean up some of this data by killing off these points that are not, which I don't find so useful. So again, it's a very quick and dirty way to do outlier detection and removal. Again, this is a pretty big, this is about 500,000 points with about 20 attributes, so it's right at the limits of this machine. So here I've done some outlier removal. I can change, also we can move some points down here. I can change the size of the points, so the selected points right now I've made quite large, so you can see them when I select them in blue. Then I can change the scale of the data points. Here's my histogram showing up again. Here, I can move this back over. And let's say I want to pick what we would call in astronomy a volume limited sample. So I'm going to change the size of those blue points and make them a little bit smaller and select those up here. So this would be what we call a volume limited sample. You can see how it shows up in the other areas, the other color attributes. And then if I'm interested in some other aspect, I can change the coloring that I'm interested in highlighting, and I can go back, change the size of the pixels for that particular highlight that I'm interested in playing with, and go in and look at those. So up here, I can look at these particular outliers here. And I can go with several different colors. So if there's several different aspects of the data I'm interested in, I can explore the data in this way, in essence, fairly quickly. I can change how the data is displayed. Right now I have it scaled min-max, but you can do different kinds of trimming, 3 sigma clipping, you can rank order the data, you can Gaussianize the data, all kinds of different things. I mean, more or less, in essence, that's what the strengths of the program are, doing this kind of multivariate data interrogation, but in a quick way, and a small subset of data. So on a laptop, it doesn't, you can look at, say, 4 views here, but if you have high dimensional data, of course, you can keep adding more rows and columns if you have a bigger screen. So it's totally expandable. I have a 34-inch display on my desk here, and I can plot up 4x4 on something like that with not too much difficulty. Here you can't see very much, of course, because this display is not so high resolution. But if you had a high resolution display, it's the perfect device for looking at sort of multi-dimensional data. Anyway, I think that's all I wanted to say and show you in terms of this product. So download it, check it out. If you want to join the development community for it, it'd be great. We'd love to get some more people with more ideas about implementing it. We have a Matlab plugin, so if you've loaded up a bunch of arrays in Matlab, you can then plot those through this interface. So if you've been manipulating your data in Matlab, which of course many of us do, then you can get it to work. We had the idea to eventually get it working in IDL for the astronomy community, because the astronomy community is heavily dependent upon IDL, but unfortunately none of us are IDL people.
There is a shift to Python.
And yeah, well, Python. Yeah, they're switching to Python, but there's some dinosaurs left. Anyway, thanks a lot. Where do you download it? Oh, yes, that was on the first. Yeah, sorry, that was on the first slide. So you go there, astrophysics.argonauts.gov/viewpoints. Yeah, if you put viewpoints in Google, you will never find it.
Yes, you will. Yes, you will. I just did.
Did you really?
Yeah.
What ranking was it?
Oh, I don't know. No, I went to Google Chrome and right in the address bar I put NASA Viewpoints.
Oh,
right.
put NASA Viewpoints. Yeah.
Came
Put
right up.
NASA. Yes, you might actually get so. Okay, so anyway, well, thank you all for coming today. I want to thank all of this afternoon's speakers. It was really great. And look forward to seeing you all tomorrow. Thank you. Have a nice evening.